Okay, there we go. Okay, so central angles, if you remember from the video, a central angle has to have its vertex at the center of the circle. Okay, so central angle, center of the circle. So if we look at this, it says a central angle is an angle with its vertex at the center of the circle, and its two sides are radii. So just FYI, radii, R-A-D-I-I, this is the plural of radius. Okay? And it says the sum of all central angles in a circle is 360 degrees. So if I were to add, I'm gonna make some other ones in here. So if I were to add this angle, this angle, this angle, this little one, and this one all the way around, that is going to be 360 degrees. So on this one, we would call, and here's the example, we would call this angle ABC. And then the degree of the arc.
Where the heck are your angles?
What? Don't have a question? Okay. So the degree of the arc, so remember, so if this is the central angle, I'm going to make this bigger. If this is the central angle, then this is what is called the intercepted arc. So think of this, and I hate using this analogy, but you can't see me. If this is an alligator, and I close the alligator's mouth, that arc is called the intercepted arc. Okay, so it says that the degree of the arc formed by the endpoints of a central angle is equal to the degree of the central angle. So if this central angle is 84 degrees, then this arc is also 84 degrees. So it says the measure of arc, and here we're going to use arc symbol. So the measure of arc AC is 84. So if the central angle is 84, then its intercepted arc is also 84. Then measure of arc ADC. So this is a major arc, which means it has to be greater than 180. So ADC means I'm starting at A, going in the direction through D, and ending at C. So if this is 84, then ADC is whatever 360 minus 84 is going to be, which is 276 degrees. So that means this major arc would be 276 degrees. Okay, let me know if people are still writing, if I need to kind of pause and let you catch up. So you can either speak or you can chat. And if I need more time writing this stuff down.
I'm good.
Nope. I'm done.
Okay, so we are going to look at number 2. And when I do circles, I like to use a lot of different colors. I wish I had more of my other colors here. I had to break down and order more gel pens or ink joy pens. Oh, I muted you. Sorry. Wish I could do that in the classroom. Okay, so you're
enjoy it while you can, Dose.
Okay, kids. So the first thing that I like doing in these diagrams is paying attention to diameters. Diameters are going to give you a lot of information. So WU is a diameter because it goes through the center and is a chord that goes from side to side. So that is a diameter. And then we my reading glasses or I don't have them. So if this is diameter, that means this is a semicircle. So how many degrees is a semicircle? Anybody?
180.
Very good, 180. So I know, let me grab my calculator. I know that this angle is 87, which means that this arc is also 87. I know that this arc is 72, which means that this angle, central angle, is also 72. So this goes back to that angle addition postulate. All three of these together have to add up to 180. So I have 180 minus 87 gives me 93. Minus the 72 gives me 21. So that means that this little sliver here is going to be 21. Notice I'm not doing any of these at all. I'm going to fill in my diagram as much as I can before I start looking over here. So if this is 21, then that means that all three of these have to equal 180. When you're dealing with central angles and diameters, because this is also another diameter, you're going to see a lot of vertical angles. So if this is 72, then this angle is also 72, which means that this arc is also 72. You with me?
Yep.
Yeah.
Okay. So I pointed this out earlier as being a diameter. So that means that this is a semicircle. So if I do 180 minus the 72, that gives me 108. So then this arc here is going to be 108 degrees, which means that this angle is also 108 degrees. Okay. Now I have my diagram filled out. Now I'm going to go back through and answer these questions. You need to pay attention to, is it an arc over 2 letters, which is a minor arc, which means it's less than 180, or is it an arc over 3 letters, which means it could be a semicircle, or it could be a major arc, which is over 180 degrees. Okay? So angle UXV, angle UXV is what, guys?
Advance.
What?
72.
72, very good. Arc ST. So arc ST, because it's 2 letters, I know it has to be a minor arc. Arc ST is how much?
21.
21, good.
Yeah, brother.
Arc. Say that again, is that John? Can't tell who that is.
Oh, hey, Mrs. Dose. Sorry I'm late.
Oh, you're good. I'm trying to figure out what the heck just happened to my chat thingy. That's all right. Okay, so WV is what? WV, so again, 2 letters.
108.
I know it has to be small, so 108. Arc TW. Arc TW, how am I going to find that?
Yeah, you add the 2 arcs.
Good, add the 2 arcs, so 72 and 21 gives me 93. And then TVW. So TVW either has to equal 180 or be greater than 180 because it's 3 letters. So it's a major for a semicircle. So T through V, so T through V ending at W. So T to V to W. So I'm going to add up all of these. So I have 87 plus 72 plus 108.
267.
67.
And you get 267. What else you could have done is if TVW goes all the way here, And these are the two that you don't have. So you could have done 360 minus your 93 also. That would have also worked. Okay, questions there?
Nope.
Everybody good?
Yep.
Okay, I'm gonna just kind of point out some things. I'm not gonna do them, but I'm gonna point some things out. So like on number 4, pay attention to the right angle indicator. And pay attention to vertical angles. So if this is 19, then that central angle is 19, which means that this arc is what?
19.
19. And again, you can find some diameters in there, so pay attention to those diameters. I would like to look at problem number let's look at problem number 6. Problem number 6.
On the same page?
Yep.
Yeah.
Okay. So hopefully everybody is unmuted. So what are some things that you should notice in this diagram?
There's a binomial.
Yep. There's a binomial. We're going to have algebra in here. What else? What's one of the first things you should be looking for?
Right angle.
Okay, don't have any right angles. What's the next thing?
What angles you have?
Okay, can you give me an example?
Angle 103 and angle 15.
Okay. What else? What was the first thing that I pointed out on this one?
Oh, your diameter.
Diameter. Yep, diameter is going to be a really important piece. First thing I notice is I have at least one diameter there. Okay. So
How many
I know-
diameters can you have in a circle?
What?
How many diameters can you have in a circle?
It is infinite. So in this particular problem, I have this diameter because it goes through the center, and I have this diameter because it goes to the center. I'm going to focus on one at a time though, and see if I have enough to do what I need to do. So if this is the diameter, that makes this a what?
Semicircle.
A semicircle.
Semicircle. So a semicircle has to be 180 degrees. So how am I going to find out? Oh man, purple marker's pooping out on me. Dang it.
Wouldn't you do 180 minus 103?
Yep. So this is going to equal 180 minus the 103.
77.
Give me 77. So that means this arc is 77. So I have this arc. I have this arc. How am I going to find this arc?
Vertical angles, right?
Yeah, vertical angle. So this arc is 77. Then this angle is 77, which means that this vertical angle is 77, which means that this arc is also 77. So the whole idea here is we're trying to set up an equation. Do you see an equation in here? I see a couple equations.
Yeah.
Could you do 18x minus 2 equals 103?
Okay, so you're telling me that you know for sure that this equals 103.
Oh, no.
No, you're on the right track though. Okay, so I see 15 plus 18 minus x plus 77. Yep, I agree with that one. So Faith said that you could add all of these up and set them equal to 180.
All right.
So that's one equation. Let's go back to Ellie's. This angle here doesn't equal 103, but doesn't both of these together equal 103?
Yeah.
So another one you could have done is 18 minus x plus the 15 equals 103. Another one you could have done. So I don't care which one you do, go ahead and solve it.
Are we rounding?
Nope. Well, if you have to, but I'm looking at all of these and they come out to be nice, neat answers.
Okay, I think I got a solid number.
What'd you get?
5.
5 is correct. So did someone get a decimal?
I did.
On which equation did you use? The
Oh,
first or the
I got
second?
it. I got it. I accidentally put a 1 in instead of just a regular 90.
Ah, okay. Anybody else not get 5? No one else?
I got 5.
Okay, so you have a good half an hour. If you turn over the paper, we are stopping here. And we are doing this later on, so don't cross it out or anything, because we are going to do this, but we're not doing it at this time. Okay, so right now you can be working on 1 through 9. So remember, I have the answer keys. So once
I
you
have
get
them
an
open as
answer,
well.
good job, Town. You're right on it.
Yes, Miss Town.
Thank you, folks.
Kids, just tell me when you want me to mute Town, because I have that control.
Mrs. Dose.
You missed the part where she muted me earlier, John.
Oh.
I told her to enjoy it while she could.
Miss Town, if I swipe, or Miss Dose, if I swipe over, I can see you.
You can?
If I swipe over, I'm on my phone, so I can see you.
Oh, interesting. I'm not picking my nose or anything, so this is pretty good. Dayton, I get that. So you guys should just be working and then letting us know what you have.
Oh, yeah, I messed up on that. Well, then.
Getting any answers yet? For verification?
Shoot.
John, I'm hearing lots of grunts and shoot and eraser marks.
Yeah, I'm on 8. I accidentally said 33 instead of 43.
Ah,
Oh, wait. 53. Yeah, that makes more sense.
where are you getting the 53 at?
Like the circle equals 100, like 360,
Mm-hmm.
and it's like, I thought 127 plus 127, and then like 53 plus 53, like 180 and 180 equals 360.
Mm-hmm.
Because I tried it out with the equations on the side, and that seems to work out. Because I'm getting 6 for 5x plus 23 equals 53, minus 23 to the 53 turns to 30. 5 equals 30. 30 divided by 5 is 6.
So you're getting X to be 6?
Mm-hmm.
I disagree.
Okay.
So on number 8, you said?
Yeah, number 8.
So if you look at number 8, those two together that have the algebra,
Mhm.
do you see how they make a semicircle?
Oh, yeah.
Okay, so you would actually do what then to set up your equation, John?
Set them equal to each other.
Think
Huh.
about that semicircle. How big is that?
It's half of the circle.
I totally agree.
Mhm.
What would the number be for that?
180.
Yes.
Oh.
Okay, I think that was your light bulb, right?
Mm-hmm.
So,
Okay.
John, did
Okay,
you do a, equal to 360?
What, Mrs. Dose?
Did you set these two equal to, or set these two equal to 360?
No.
No. Okay. So I'm just going to kind of add on to what Tom said.
Okay.
Again, check out those diameters. But if you'd recognize this arc and this arc are going to be the same,
Mm-hmm.
and then this arc and this arc are going
Would
to
be the same.
then you could have done all 4 of these and set equal to 360. That's a lot more math. So that's why I suggest finding those diameters. So you're cutting your equation down by half of it. Does that make sense?
So I could like add 5x plus 23 to 17x minus 41 instead of equal to 360.
Well, if you're just using these two
Yeah.
equal how much?
180.
180.
Oh,
But if
okay.
but if you did 5x plus 23 plus 17x minus 41 plus another 5x plus 23 plus another 17x minus 41,
That wouldn't make sense.
that would be 360.
Oh, okay. All right. I think I understand now. Thank you, Mrs. Dose. Thank you, Mrs.
No problem.
Yes, Jaden.
I have a question.
Yep.
I can't figure out, like, on number 1 for measure of arc JKM and then measure of arc MKL. I don't know how to find them.
Can you repeat that, Ellie?
I don't get how to find the measure of arc JKM and measure of the arc of MKL.
Okay, so did you fill in all your measurements?
Yeah.
So JKM, that means you're starting at J.
Can you move the paper up? There we go. Okay.
Okay.
Yeah.
So if you're starting at J, you're going through K and ending at M.
So it'd be both 21s plus the 159.
Plus what? Oh, you say both
21.
21s?
Both 21s and then the 159.
Yes.
Yes.
Okay.
And again, kind of taking a shortcut leading back to what John was doing. If you recognize this as being a diameter, so there's your 180 plus your little 21 there.
Okay. So then would it be 21, 159, 159, 201, and 339?
Yes.
Perfect.
Yep. Jaden, did you figure that out? Okay, good.
Mhm. This is Dose.
Yep.
On number 8, does it come out to be a decimal or a whole number?
Whole number.
Okay, I got 16.5.
What
X?
equation did you use, John?
I set 5x and 17x to equal 180.
Oh, okay. You need that whole algebraic expression. So the 5x plus 23,
Mm-hmm.
and then add on the other entire algebraic expression, the 17x minus, I think it's 41. Sorry, it's really small on my phone screen. And have that equal 180.
Okay,
Yeah, you just forgot those two numbers.
thank you.
No problem.
So it'd be really helpful for Mrs. Town and I is if you text some people in classes for Geometry C
Mhm.
and kind of let them know that we're doing the online stuff. I've been sending out emails, but let them know we're doing the online stuff. Let them know to follow the agenda.
I got David's number. I can talk to him about that.
That would be great.
That'd be great.
I asked Skylar if she was getting on today, but her computer's dead and her charger's at her dad's, so she couldn't log on. But I told her I would help her when we get off with this.
Good, thank you. Please tell me you stopped recording. Gosh dang it, I didn't.